All right, so the next thing that we'd like to consider is the relationship between various entities, right? And in particular, we have the relationship between users, right, having a one-to-many relationship with websites, and then each website having many pages, and then each page and then having several widgets, right? One-to-many widgets, correct? In a relational database, typically the way you implement this is that the parents, right, on the strong side, on the one side, right, declares a primary key, right, and then all the children on the weak side, right, declare a foreign key that refer back to its parent, right. So each child knows who the parent is, right. That's a very common way to implement that using relational databases, right? And then you can just drive that all the way through, right? So you have a primary key here, right? And then you have a foreign key. Each page knows who their parent website is. Each widget knows who the parent page is, right? And certainly that is one of the things that you're going to be implementing in the assignment for this week. But this is not the only way that you can implement it in Mongo. Mongo certainly allows you to do this, right? And you'll implement it that way. The other thing that Mongo allows you to do is how it should feel a little more natural if you're coming from an object-oriented programming language, right? Typically, in an object-oriented language, you have the parents have references to their children, right? Either as a collection or array or linked list or whatever collection data type you're using. It is a parent who has an array or collection of the children, right? So it is the user who has an array of websites. The website has an array of pages, and the pages has an array of widgets. And the assignment asks you to implement it that way as well. Now, typically you wouldn't do both, but I like you to practice on how to do it using it from the parent to the child. So Mongo allows you to do it either way. Okay, having a user object. So here's a user object that might have a username, right, Alice, right, and one of the fields will be websites. So websites, right, and in this array we're going to have IDs, right, of the child elements. So if you have one user, user one here, right, referring to several websites that are related to that particular user, that there will be an array that keeps track of all those IDs, right? So there will be IDs here, W1, W2, whatever the IDs are. It's those long numbers that we saw just now, right? The underscore IDs, those IDs, right? Those unique identifiers, and these IDs are referring to those other instances of objects that live in the data space, right? Now, typically in a relational database, you can use these references of the children referring to their parents, so that you can join these things together, right? You can say, hey, I have some information of the user on this side, I have some information of the website on this side. I want to join back together the data between the two. In Mongo, there is no such thing as joining, right? The closest thing that there is what it's called populate. Populate is an object-oriented way of implementing something that looks like joining, meaning if I give you this ID, I can then ask you to populate, right? Populate whatever object is referenced by that ID, meaning do an additional fetch, right? Do this using this key, right? This primary key. Go again back to the database, fetch me the object, right, that is referenced by this. And then replace this, right, with the actual object, right, with the actual object. So now, if I populate this array, this won't be an array of references, it'll be an array of actual objects in there. Okay, almost like a join, right? This is a merging of data that is from the parent merging with data that lives on the children. Okay, but notice that it's encoded, right, in a fairly complex or more complex JavaScript object, a JSON object, an object that includes an array that includes objects, right? And certainly JavaScript allows you, and MongoDB allows you to encode this in any arbitrarily complex JSON objects, right? And that brings us to the third way of doing this, right? So we saw that the relationships can be done in two ways, right? Either the parent has arrays of the children, or the child. That's one way to encode relationships. Or the child has references back to its parent. That's a second way. Mongo allows you to do it a third way. Allows you to do it a third way. Okay, and basically it's based on the fact that we can flatten this model instead of having it like this, which is nicely normalized, right? Where you have each entity represented in its own table, its own collection. Mongo allows you to flatten this out, right? Flatten it out into one single denormalized schema, right? So when you can tell it is that, hey, this is an array. This is an array of objects that have the following attributes: title, string, description, string, pages is an array, right? And in here you can go and put another schema. Pages are made up of what? Again, other fields: title, string, I think also description, string, and then widgets is another array of objects, right? Which have type, which is the type of the widget. What else? Widgets are made up of types, width, text, right? Size. There's a whole bunch of attributes in there, right? Notice that there's only one collection. There's only one collection, the user collection, that contains everything else, right? We wouldn't have a separate collection of websites, a separate collection of pages, a separate collection of widgets. Okay, right? This is a denormalized implementation where it flattens this whole thing, right, and it includes this schema inside of the array in the websites array. It includes the schema for the pages inside of the array of in the parent website and the widgets as well. Okay? And Mongo suggests that if you have the chance, right, if it's a brand new project and if the use cases allow, right, this is the way you should go. Right? That if you log in as a user, right, you immediately get back all the data associated to that user, all the websites, all the pages, all the widgets and whatnot. If you're allowed, if the use cases allow, and if it makes sense, right, if it also makes sense, you would do a single query to the database, right, and for that one user, you would retrieve all the data that you need. There's no need to go back to the database to go fetch anything, right, and you cache it wherever you need it. Okay. Again, only if the use cases allow. For instance, in our case, it doesn't make sense. Right? It doesn't make sense, right? That if I go into a user and that I'm going to retrieve all the websites, all the pages, all the widgets that I'm probably never going to use, right? I might be working on a particular website and never touch, dozens or hundreds of pages and thousands of widgets that make up my website, right? That I'm never going to need. Right, so in our use case, it makes no sense. Maybe it might make sense to do it when you fetch a particular page, right? When you fetch a particular page, it might make sense, right, to retrieve the array of widgets already embedded in that page without having to go fetch each individual widget. That might make sense, right? Right. It might make sense to perhaps drop the widget collection, right, and just embed the schema for that widget just inside of the page. That makes sense, right? If I go fetch a page, bring me all the widgets as well, right? But it might not make sense that if I retrieve a user, I'm going to also fetch all this entire thing. So it depends, right? Also, it depends if you have use cases that require the individual, being able to treat this entity all by itself, regardless of any relationship that there might be with other entities, right? So, for instance, an administrator might want to list all the websites, right, across all users, right, irrespective who the developer is, right? If you use this encoding, it would be very inconvenient, right? It would have to fetch the users and then for each user iterate over all the arrays of the websites and retrieve each website instance and then create one large collection. It would just be very, very inconvenient to retrieve it that way. So whenever you need, if you have use cases such as that, then it makes more sense to have its own dedicated collection, right? So in our case, I think it makes sense to have a collection of users, websites, pages. Perhaps maybe we could drop the widget schema, right, and just embed it inside of pages. Right? All right. So I'd like to focus now on start working with these relationships, right, of creating websites, creating users, and creating the relationship between those two. All right. All right. So let's focus on that now.